everyone, welcome back to my channel. I am student of Sri Venkateshwara College of Engineering, Bangalore. I am A. Purnaseshan, Department of Information Science and Engineering. Today our main topic of presentation is CAD. Let me abbreviate CAD. CAD is nothing but computer aided engineering drawing. Let us see the topic on about what we are going to discuss. I am going to discuss about introduction to CAD and next quadrant system and projection of planes and two problems based on projection of planes. Let us see the introduction to CAD. So CAD is nothing but a basic level of engineering drawing, mainly used by civil engineers for seeing buildings, planes, solids, etc. in 6 different views. In CAD, we are going to discuss only about 2D objects. So let us see the quadrant system. There are totally 4 quadrants. First quadrant is represented by the sign plus and plus. Second quadrant is minus and plus. Third quadrant is minus and minus. Fourth quadrant is plus and minus. But in CAD, we are going to discuss the first quadrant in terms of horizontal plane and vertical plane, also called as HP and VP. Horizontal plane can also be called as top view and vertical plane can also be called as front view. So let us see the naming of horizontal plane will be in the terms of A, B, C, D, E, and in terms of vertical planes it will be A dash, B dash, C dash and D dash. Now first quadrant in the quadrant system is in the CAD, it is represented as above HP in front of VP, and second quadrant as above HP behind VP, third quadrant as below HP behind VP, fourth quadrant as below HP and in front of VP. So in planes we are going to discuss only the first quadrant, that is above HP in front of VP. Let us see the projection of planes. We are going to show only in the first quadrant projection of planes, that is above HP in front of VP. And we are going to show for many planes like square lamina, triangular lamina, hexagonal lamina, pentagonal lamina, etc. In case of square lamina, the dimensions are 90 degree. In case of triangular lamina, the dimensions are 120 degree. If it's resting in edge, we have to show it in the left side. If it is resting in the corner, we have to show the corner to the left side. So this is all about projection of planes. Now let us see the two basic problems of square lamina and triangular lamina. Our first question is, a square lamina of 30 mm side rests on HP with one of its edge. The surface makes an angle 45 degree to HP. The edge on which it rests is inclined to VP at 30 degree. Draw its projections. So firstly I am opening solid edge and we need to draw an XY line first. So the XY line dimension should be a thin line, that is 0.13 mm. So this is an XY line. Let us name it as X and Y. X, now Y. And now we need to draw a square lamina of 30 mm sides. So click on this rectangle and give the width as 30 mm, and even height is same 30 mm, angle is 0 degree, and the square lamina edges should be a thick line. So select 0.50 mm for thick line. So this is square lamina of 30 mm sides resting on edge. So resting on edge on HP. So wait, I forgot to name HP and VP. So in planes always we need to draw angles in first quadrant. So HP will be below XY line and now VP will be above XY line. So our first part of the problem is done. We have drawn an square lamina of 30 mm side resting on HP. Now let us name the square lamina as ABCD. So first side I am naming it as A, second side B, third side D, and third side C, and fourth side as D. The naming is as per your convenience. You can name it as PQRS also. And let us project these lines to the XY line. So now I am going to draw the projections of square lamina. The projection should be a thin line. So I am selecting 0.13 mm. I am projecting it. And now we need to draw a through line. Through line should be a thick line. So 0.50 mm. And now let us name the true line. During naming we need to remember one thing. So B is visible but A is not visible. We can find this, whichever side is near the XY line will not be visible to us. So we need to name it as B dash bracket A dash, and here also same C dash bracket D dash. So let us name it. First one is B dash, bracket A dash. And second one is C dash bracket D dash. C dash bracket D dash. Now let us see the second part of our question. The surface makes an angle 45 degree to HP. Now we need to incline the square lamina 45 degree towards HP. So let us draw a 45 degree line first. So the 45 degree line should be a thin line. So let us give the length. Length is as per usual random length. I am giving 90 mm. And angle is 45 degree. So this is a 45 degree line. I am placing it on HP. Now we need to place this true line on this 45 degree line. So this true line dimension is 30 mm. So we need to draw from here to here 30 mm. So I am going to select a thick line. We can directly give it as here 30 mm and angle 45 degree. So this is a true line. Now let us give the same naming as we have given before. B dash bracket A dash. And C dash bracket D dash. And now we have to project these lines downwards. So as I told before, projection line should be a thin line. So I am selecting thin line and I am projecting it downwards. And now even from here I need to project them. And now I need to draw the thick lines. So thick line should be 0.5 mm. So this intersection symbol, this cross symbol shows it is the intersection, the line is meeting. So from there to here, then from here to here, then from here to here. Sorry, a small mistake. Control Z. We need to draw exactly or else we'll get some errors. From here to here and from here to here finally. So now we have to name this as before ABCD. So let us go to the text. A B C D. So even our second part of the question is done. Let us see what we have to do next. Then the edge on which it is rests is inclined to VP at 30 degree. So the edge is inclined to VP at 30 degree. So this is the edge which is inclined and it should be inclined to VP at 30 degree. So let us draw a 30 degree line. So 30 degree line should be a thin line. So let me select thin line and length 90 mm and angle 30 degree. I am giving it as minus 30 degree because it is in VP. Enter. So this is a 30 degree line. I am placing it here. So this is the edge on which it is resting. So we have to place this edge over here. So let me go to the move option. Okay, this is the move option. So this edge, I am taking one edge and I am placing it here. So we need to rotate it so that it rests on the edge. So click here. So this is the rotate option. We need to select the whole square lamina. Then we need to click on it. We need to select any two edges. Okay, this is the copy button. This should be off so that your image is not copied. Now we can rotate it. Where is rotate option? Rotate. Okay, copy is off. Now I'm selecting two edges. Okay, our third part is done. Now we have to project this line towards upwards. So for projection, let us take a thin line. So it's already thin line. Now let me project upwards. And we have to project even these lines. So let us draw the square lambda, the final projection. So let us take a thick line. So this is A, B, C, E. So this is our final projection. Let us name it A dash, B dash, C dash, B dash. So this is our first projection on planes which we have drawn. So now let us show the dimensions. So go to smart dimension, click on any one edge. So done. And now this one, and this one, and let us show the angle, this angle between. So this and this is 45 degree. So this is our final output of what we have drawn. Now let us see our second question. A triangular plane figure of size 25 mm is resting on HP with one of its corners such that the surface of the lamina makes an angle 60 degree with HP. If the side opposite to the corner on which the lamina rests makes an angle of 30 degree with GP, draw the top and front views in this position. So firstly we need to draw a triangular lamina of 25 mm size. So let us go to solid edge and draw an XY line first. XY line should be a thin line, so I am selecting 0.13 mm. So this is an XY line, we need to name it as X and Y. Yes. Now we need to draw a triangular lamina of 25 mm size. So the lamina side should be a thick line. Let me select 0.50 mm, 25, enter, 0, enter. Then next it is 25 and 120. 25, 120, enter. Next it is 25 and 240. You need to add plus 120. So 25, 240. So this is a triangular lamina, but it's not resting on corners, so we need to rotate the lamina. So for rotating we need to select any two sides. So this is first side, second side. So now it's resting on corner. Now let us draw the projection towards XY line. So for projection should be a thin line. Now let us name the lamina. A is visible. Here B is visible but C is not visible, so this side should be in bracket because it is near XY line. So I'll name it as B. A is visible, B is visible, but C is not visible. You can make it very clear when any side which is near to XY line will not be visible. So we need to name this in brackets when we draw the true line. So let me draw the true line. So true line should be a thick line. So this is the true line. Now let us name the true line. A dash. And B dash bracket C dash. As C is not visible. B dash bracket C dash. So our first part of question is done. Now let us see what we have to do next. The surface of lamina makes an angle 60 degree with HP. So we need to draw a 60 degree line and make this triangle lamina inclined to that 60 degree line. So for that, select the thin line, give length, okay, select thin line, length is as per wish, I am giving 90 mm, no 120 mm I will give, and angle is 60 degree. So this is a 60 degree line. Now let me place the true line over the 60 degree line. So let us take the true line dimension first. So true line dimension is 21.73. So we need to place the 21.73 line on this 60 degree line. So I am selecting line. It should be a thick line. Length is 21.73. 0.73. Enter. Angle is 60 degree. So this is our true line. I have placed it. And now we need to name it as same as before. A dash and B dash bracket C dash. A dash. B dash bracket C dash. B dash bracket C dash. Okay. Now we need to project it downwards. So projection line should be a thin line, 0.13 mm. Even this original triangle we need to project it. Now let us draw a triangle. It should be a thick line. Now exactly from here to here. So when you get that cross symbol, you need to click it from here to here. You need to join it up. So our second part of the question is done. Let us see the third part. So, if the side opposite to the corner on which the lamina rests makes an angle of 30 degree to the VP. So, the side opposite to the corner should be inclined 30 degree towards VP. So, let us draw a 30 degree line first. So, I am selecting a thin line. Let me keep it as 120 mm and angle is 30 degree. So, it is minus 30 degree because it is towards VP. So, minus 30 degree. I am placing it over here. Now side opposite to the corner. This is the side which is opposite to the corner. Let us name it first. Yeah. So the side opposite to the corner is B and C. So we need to place this B and C in this 30 degree line. So let us move this line. So let us copy this whole thing. Click on this copy option. Bring this over here, place it, and now let us rotate this. So for rotating we need to click on any 2 points. This is the first point, this is the second point. So even our second part of question is done. Now we need to project this upwards. So for projection let us take a thin line. So it is already a thin line, so let us project it upwards. No, it is a bit fast. Once more let us do. Then from here to here. From here to here. From here to here. This line bar symbol shows it is a straight line. And now let us draw the triangular lamina. Even this one we need to project. From here to here. So for drawing the final position we need to take it as thick line. So this is A. This cross symbol shows, so we have to click it over here. From here to here, A, B, C and A. Let us name it. Yes. 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 So finally, this is the top and front view of triangle lamina. So this finishes our question. I hope you all have understood my presentation. If you want to download this SolidJet software, I have provided the link in the description. Thank you.